All right, there we go. Okay, the goal for today for us is to learn how to multiply polynomials and use special products. There's a lot of stuff coming at you today. All right, so to start with, let's talk about multiplying polynomials. Okay, whenever you have two binomials, you can use a method called FOIL. Who has heard of the FOIL method before? Yes, most of us have, right? It stands for first, outer, inner, last. First, outer, inner, and then finally last. Okay. If you like FOIL, go ahead and use the FOIL if you want. I personally like the box method because FOIL can only be used when you have two binomials. That's the only time you can use it. So I would much rather, when I'm multiplying polynomials, I would much rather use the box method. So let me show that to you. Okay. So let's say, for example, that I wanted to multiply these two binomials, x plus 3 times x minus 1. Now I could use FOIL because those are two binomials, but I'm going to choose to use the box method. It looks like this, okay? Put one of the binomials, x plus 3 at the top.
It's like a Punnett square, isn't it?
That's exactly right. For two binomials, it becomes a Punnett square, like this. And then put x minus 1 on the bottom over there. So here is what you do. You just multiply these two together. So ask yourself, what is x times x? X squared. Good. What's x times 3? 3x. Good. What's x times negative 1? Negative x. And what's negative 1 times 3? Okay, now the cool thing about the squares is that if you set up each polynomial in standard form, like they are here and they are here, then the diagonals will be like terms always. That's pretty cool. Yeah, so therefore your answer will be x squared. 3x minus x is a positive 2x, and then minus 3, and life is good. Okay, what do you think about that? Not too bad, right? Okay. The rest of the day is denoted to all of the special products because there are quite a few of them. And here, the first one that we're going to talk about is the difference of two squares. All right, so the difference of two squares, so this one you definitely want to memorize. Okay, so memorize this one. So I'm going to give you the rule. Okay, here's the rule. The rule says this: if you are multiplying x plus a, so a binomial, times x minus a, notice that the a's are the same. The a's are the same, and the only thing that's different is the minus and the plus sign between them. Then you are guaranteed to have this turn out to be x squared minus a squared. So that right there is super important. Where's the big fat one there? Make sure you look at that one. Okay, so let me give you an example for that. All right. If I was gonna do x plus 2 and then multiply that by x minus 2, well, I could use FOIL. That's one of my options. I could also use a box method. That's another option. But I'm noticing something, right? I'm noticing that each of these terms are the same value, right? So if I have x plus 2 times x minus 2, then I can go straight to the formula and say that's going to be x squared minus 2 squared, which is what? And that's the answer. How sweet is that? Yeah, that's pretty sweet, right? You want to try another one real quick? Try this. What's x plus 3 times x minus 3? Use the formula. What do you get? X squared minus 9. There you go. Look how fast you're doing. Look how fast you're multiplying those binomials. X squared minus 9. Like butter. All right. So there's our first special product, the difference of two squares. That one definitely want to memorize. All right. Let's kick it up a notch here to these harder ones here. Okay, let's talk about perfect squares. Whoa, you okay?
Yeah.
Make sure you memorize this one too. All right, the perfect squares. I'm gonna give you the rule here and tell you what the most common mistake that everybody makes is. So here is the rule. If I want to take x plus a and square it, okay, x plus a and square it, that literally means, right, take x plus a and multiply it again by x plus a, okay? So in the end, when you use that, you get this, x squared plus something, and this is the piece that everybody forgets, plus a squared, okay? And the piece that everybody forgets in the middle is 2xa, so don't forget this one. Don't forget that one. That's the piece that everybody always leaves out, okay? And the same thing is for if I was going to do x minus a all squared. It would be x squared in the front, a squared in the back, 2xa in the middle. The only difference is a minus sign in the front.
Why is it 2xa?
Yeah, where does that 2xa come from? Is that what you're asking?
Well, I don't know. Wouldn't it be 2ax? Like,
Oh, that's the same thing, right? What's 3 times 4?
4, 12.
What's 4 times 3?
12.
So multiplication's allowed to switch back and forth, right? It doesn't matter. That's commutative, right? So we don't worry about that. So there's the rule for that one, okay? And the biggest mistake that people make is they forget to leave out that middle term. Yeah, they just say this. They say, oh, it's just x squared plus a squared. And that's the biggest thing that's the biggest mistake everybody makes. So let's try a few examples, see if you can get it. What is quantity x plus 3 all squared? I'm taking a binomial and I am squaring x plus 3 all squared. All right, well, let's see here. According to the formula, it's going to be the first term squared. So that's just going to be an x squared. In the back, it's going to be an a squared. So in this case, the 3 represents the a. So in the back, it's going to be what? 9. So what's in the middle?
6x.
So yeah, 2 times 3 times x. I'll write that out. 2 times 3 times x. So the answer is x squared plus 6x plus 9. What do you think about that?
2.
Where do I get the 2? Yeah. So where do I get the 2?
From the formula.
From the formula. Are you talking about this 2 right here?
Yeah.
Like, where does this 2 come from?
Yeah.
It's part of the formula. Right there and right there. Now, yeah, why does it show up? I'm so glad you asked that. Let's go back up here. If I was going to do a little side note, if I was going to do x plus a, okay, and multiply that by another x plus a, can you guys see that? Okay. And do the box method, right? Here's what I would have. What is x times x? X squared, that's where this comes from. You with me? Okay. What is x times a? What is a times x? Ax. What's a times a? So the a squared, that's where that one comes from. So we know where that one comes from, and we know where this one comes from. Now, if you have one xa and another ax, are those the same thing? Because you multiply them together. So how many ax's do you have?
2.
That's where the 2 comes from. No, you're adding those together. You're adding those together, not multiplying them. You're adding them together. Click on that.
You can pause it?
Oh, absolutely. Absolutely. Okay, try this one on your own. All right, try this one on your own. Can you give me what's x minus 5 all squared? Try that one on your own. Now, I'm going to give you a more challenging problem. Are you ready? I'm going to throw a wrench into the problem. Here it is. 3x plus 5 all squared. Okay, somebody tell me, why is this so different? What's the big deal? Why is there a wrench thrown in this problem? Yes?
3x.
Well, not the 3x, but just the 3. What is this called again? Yes, the coefficient. Very good. In front of the variable. All of that needs to be squared. So try that one. Where'd you go? You gotta do those? Okay. All right. We are moving on. What, is this the 4th box?
Oh, I thought this was all in special products.
Well, yeah, I mean, this is all part of special products. All of these things are called special products. Okay, perfect cubes, you don't have to memorize. Yes, you do not have to memorize those right now because we studied them later in depth in the binomial theorem. I'm just going to give you the rules right now so you can use them. Rule says this: if I want to take x plus a and cube it, okay? X plus a all cubed. Well, the 3 on the exponent on the outside literally means x plus a times x plus a times x plus a again, right? Well, we're going to bypass all that because we have a rule. And it looks like this. Take the first thing and cube it. X cubed. Okay? Now, add to that 3 times the first thing squared times the last thing. Okay? Say again? Okay. Add to that 3 times the first thing times the second thing squared. So just reverse the exponents. And lastly, take the last thing and cube it. Now that looks really mean and scary and nasty, but it's not that bad actually. Okay? And let me quickly give you x minus a all cubed. Okay? What I'd like you to do is rewrite the exact same thing you just did, except leave the signs out, okay? So x to the third, and then a 3x squared times a, and then a 3x times a squared, and then finally an a cubed. The only difference between these two is a subtle change in the signs, okay? This first one right here is negative, positive, and negative. That is the only difference between the two, so I'll point that out to you. Notice those are the same, and those are different. That's the only difference. Like I said, you do not have to memorize this one because we study it in depth later, but I'm just giving it to you now so you have it in your notes. Alright, are you ready to use it?
Is that on the homework? The cubes?
Yes, it is. Well, it'll be on our work for tomorrow for sure. Yeah. Tomorrow's a block day, so we have some time. Or next time I see you guys. All right. Stay with me here. Let's do some examples. Let's see if we can use this. Okay, what would x minus 4 to the third all be? All right, well, let's identify a few things, okay? The x, of course, is just the x part right here. So that part is going to take up all of these x's up in here. Does everybody see it in the highlighted in the yellow? Okay. Now, I'll take a different highlighter and I'll go green. Okay. This 4 right here is going to represent this A, and that A. Does everyone see it in the formula? I'm breaking it up for you with the colors. No. No, they're not all green. One's yellow and one's green.
Holy cow.
If I had a better projector, we could be able to see that.
Those are yellow?
These are yellow, right there, there, and there, and these are green, here, here, and here.
Oh.
If you watch the video tonight, it'll be nice and crisp and clear for you, okay? Sorry about that. Okay, now, here we go. Take the first thing and cube it, so that's x cubed. Minus 3 times x squared times 4.
X squared or x cubed? Oh, it's
X
x
squared.
the negative on it?
Yeah, I'm glad you pointed out. We do not need to take the negative sign with us because the formula accounts for it. It's a great, great question.
Good job, Brody.
Okay. Then I'm going to add 3 times x times 4 squared. And finally, subtract 4 to the third. And all we have to do now is simplify. So x to the third. Let's see here. 3 times 4 is 12, so that's 12x squared. 4 squared is 16. 16 times 3 is how much? 48x. And then lastly, 4 cubed is 64. How fast was that, you guys? So fast. All right. I'd like you to partner up with someone and